This video is to go through the review sheet for both the college prep pre-cal class and the honors pre-cal class for their test on rationals, variations, and some polynomial stuff. But I need to make sure one thing is clear. The review sheets do have some differences. I will try to make sure I make it clear where it is. Honors, you have two numbers, number 12 and number 16 on yours, that I'm going to put at the very end of this video because it is not in the CP pre-cal review. So I'll try to alert you to any other differences about numbers or anything, but you will see all of your problems in this. And number 12 and 16 on the honors pre-cal will be the very end. CP pre-cal, this will look exactly like yours. It's all good. Okay, let's begin. First, we're trying to find vertical and horizontal asymptotes. So remember, vertical asymptotes are found at numbers that make the denominator 0 but not the numerator. So in number 1, the number that would make the denominator 0 is 1. So that would make the denominator equal 0. And if we plug it in the top, that does not make the top 0. So we do have a vertical asymptote at x equals 1. That's a number that does make the denominator 0, but does not make the numerator 0. So I think I'm actually just going to keep going with vertical first. We'll come back to horizontal. So honors on yours number 2, you would have to factor it in order to see x plus 3, x plus 8. But that's what you should do anyway. And then we set both of those equal to 0, and we get x equals negative 3 and x equals negative 8. Neither of those make the numerator 0, so they are both vertical asymptotes. Number 3, if we set x plus 5 equal to 0, we get x equals negative 5. And there's no way it's going to make the numerator equal 0 because there's no x up there. So we have another vertical asymptote of x equals negative 5. And for number 4, it is 8 that would make the denominator equal 0. And that does not make the numerator equal 0. So x equals 8 is the vertical asymptote. So let me just quickly tell you guys what it might look like if it was not a vertical asymptote. Let's say I had x minus 7 over x minus 7 times x plus 2. Both x equals 7 and x equals negative 2 make the denominator 0, but 7 would also make the numerator 0 in this problem, so I'd have to throw that one out. It is not a vertical asymptote if it makes both the top and bottom of the fraction equal 0. Now switch over to horizontal asymptotes. For these, in general, we look at the exponents. So on this first one, we have x to the first, x to the first, they're the same. So we look then at the coefficients in front of them, and we get 2 over 1, so it's y equals 2. Make sure when you're writing answers to these, you do put x equals for all the vertical and y equals for all the horizontal. Okay, for number 2, if you FOIL out the bottom, you get x squared and then some other stuff. But as far as the exponents, it's clear that the bigger exponent then is on top. So when the bigger exponent on top, we don't have a horizontal asymptote. For number 3, the bigger exponent is on the bottom because it's x to the first, and there's just x to the 0 on top because there isn't one. So if it's bigger on the bottom, the horizontal asymptote is y equals 0. So those three give you pretty much one of each type. Number 1, powers are the same, use the coefficients. Number 2, powers bigger on top, there isn't one. Number 3, powers on the bottom is bigger, so the horizontal asymptote is y equals 0 in that case. And finally, number 4. This one is a little bit different, and it's because it's got this number out here to the side. So there's two ways you can think about it. It's just going to be that number out to the side, in which case it's y equals negative 2. Okay, another way you can think about it is look at these two pieces separately. If we look at the fraction 3 over x minus 8, the power is bigger on the bottom, so looking at that by itself, we might think that the horizontal asymptote would be y equals 0. And that by itself, it would be true. But then this minus 2 right here is then shifting the whole graph down 2, which makes the horizontal asymptote move from 0 down 2 to negative 2. So whenever you see a fraction with a number out of the side, added or subtracted, that number out of the side is going to end up being your horizontal asymptote. Next up, these are all identical on both of yours, so no problems we need to worry about here. We want to talk about the shifts and the transformations. When we're dealing with rational stuff, we have to think of the denominator as the inside, so to speak. So on number 5, we are adding 5 to the x, just the x, because it's basically on the inside of the denominator. So when you add 5 to just the x, that's going to shift it left 5. Over on number 6, the 7 is being subtracted outside the denominator. So that tells us that is going to shift us down 7. And the 3 is on top. So it's not on the inside, it's on the outside of the denominator. So that's going to vertically stretch us. On number 7, first, the negative we see is out front. So that means it's treated as the outside, so it's going to be a vertical reflection. It's reflected across the x-axis. The 2, that is inside the denominator. So that means it's horizontal because we think of it as inside. It's greater than 1, so it's a horizontal compression. And that 5 is on the outside. It's not inside the denominator, it's outside it, so that's going to tell us it shifts up 5. On the paper copy of the review answers that I gave you, I color-coded all these to make sure you knew what went with what. Now number 8, the 2/5, that's on top. You can think of that as 0.4 if the decimal's easier for you. But it's on top, so it's outside the denominator, meaning it's a vertical change, and since it's less than 1, it would be a vertically compressing. And then that minus 3 is inside the denominator, so it's going to be a change to the right. So it's going to shift it to the right 3 units. Okay, number 9 and number 10. We are thankfully able to use synthetic division on both of these. Remember, we know that by looking at the x in the denominator. If the x in the denominator has both a exponent and a coefficient of 1, then we are allowed to use synthetic division. So you guys are normally great at synthetic, so I'm going to go pretty quickly through these. But we start with a box where we put the number that would make the denominator equal to 0. Then we look at the coefficients on the top, 1, -4, -11. We bring down the 1, multiply it by 2, add those together. 2 times -2 is -4, add those together. So remember, we're dividing, so it goes down by 1 degree. We had x squared, now our first term is going to be x, and then the -2 is the constant, and the -15 is the remainder, so it gets put over x minus 2. So our answer should look like x minus 2 minus 15 over x minus 2. Number 10, very similar process. We'll put -3 in the box because that's what makes the denominator equal 0. Then we use the coefficients, 1, 7, and 13. We bring the 1 straight down, -3 times 1, 7 plus -3, -3 times 4 is -12. Bring that down, it's a 1. So we reduce it from a squared down to an x to the first. Then the 4 is our constant, and the 1 is our remainder. It gets put over x plus 3. So your answer should look like x plus 4 plus 1 over x plus 3. Now 11, sadly, we can't use synthetic. We've got to use long division on this. Ooh dear, here we go. It's a bit of a beast, so stay with me. We have to use long division because of this 3 right here. When it's a coefficient other than 1, we can't use synthetic. So instead we'll do 3x plus 1 being divided into 3x cubed minus 5x squared plus 10x minus 3. So we divide, multiply, subtract, bring down. We start by dividing 3x cubed over 3x. The 3's cancel, and we can reduce one of the x's, so it's x squared. So we've divided. Now we multiply that by both of these pieces. X squared times 3x is 3x cubed. X squared times 1. And then we subtract both of those. 3x cubed minus 3x cubed is 0. Negative 5x squared minus 1x squared is negative 6x squared. And we can bring down the 10x. So we divided, we multiplied, we subtracted, and we brought down. Now we divide again. Negative 6x squared divided by 3x. Okay, we can reduce one of the x's, and negative 6 over 3 is negative 2. So that result is negative 2x. Now I multiply. Negative 2x times 3x is negative 6x squared. Negative 2x times 1 is negative 2x. Then I subtract both of those pieces. Notice I'm putting the parentheses there to make sure I remember to subtract both pieces. The 6x squareds cancel. I get 10x minus a negative 2x, which really means I'm doing 10x plus 2x, giving me 12x, and I bring down the minus 3. So I've got to divide one more time. 12x over 3x. The x's cancel completely. 12 over 3 is 4. So then I multiply 4 times 3x and 4 times 1. I subtract both of those. The 12x's cancel. Negative 3 minus 4 is negative 7. So negative 7 is my remainder because I can't divide it by 3x. There's no x in it. So my remainder is negative 7, and I put that over 3x plus 1. So my final answer is x squared minus 2x plus 4 minus 7 over 3x plus 1. Okay, now just a reminder for the next problem, if you're in honors, the number 12 on your sheet will be done at the end of this video. What I'm about to do that says number 12 on the honors sheet is actually number 13. So you do have this next one, it's just numbered differently. Hope you'll forgive me for trying to combine both, but just trying to save some time. So moving down to number 12 for CP, this is number 13 for honors. We're told y varies directly as x, so that tells us to be multiplying. So y equals k times x, and y equals 42 when x equals 7. Divide both sides by 7, we get 6 equals k. Our equation is y equals 6x, and it says find y when x is equal to 5. So we get y is equal to 30. Okay, next one, number 13 on CP. Honors, this is number 14 for you. If y varies inversely, so it's inversely, so we divide. Y equals k over, it says the square of x, so I put x squared on the bottom. It says y equals 6 when x equals 3. So I get 6 equals k over 9, multiply both sides by 9, I get k equals 54. Y equals 54 over x squared, and it says find x when y equals 9. So hopefully you've gotten the pattern down here. When we have a denominator with a variable in it, we want to multiply both sides by that denominator. It gives us 9x squared equals 54. Divide both sides by 9, and we take the square root. So we get plus or minus the square root of 6. Don't forget to put that plus or minus. And I would prefer you leave the answer as the square root of 6 instead of the decimal form. Okay, CP number 14. This is also number 15 on the honors. Says suppose y varies jointly with x and z. Jointly means we multiply. So I'll do y equals k times x times z. Y equals 20 when x equals 2 and z equals 5. So I multiply both sides, 2 times 5 is 10. So I divide both sides by 10 and I see that k is equal to 2. So I have y equals 2xz. It says find y when x is equal to 14 and z is equal to 8. So when I multiply all that together, I get y is equal to 224. Okay, honors, you're about to hit 16 on your sheet, but keep in mind that'll show up at the end of this video. Okay, this is number 15 on CP. It is actually number 17 on the honors one. So easiest to do this in the calculator, so I'm going to pull that up. We want to determine if the following numbers are roots of this equation. A number is a root of the equation if when you plug it in, the result is 0. So another word for root is x-intercept or 0 of the equation. So I'm going to plug this in just using x instead of a, which is completely fine. X cubed minus 3x squared minus 3x minus 4. Sorry, I lost something there. Let me see if I can get it back. Here we go. So I have the equation plugged in. Now I want to know if these three numbers are roots. So I go to the table. I'm going to look at these numbers and see if they make the equation equal 0. Alright, I'm going to change my table by going to Second Table Setup. It's right at Window. And change the independent to Ask. So it will let me plug in whatever numbers I want. I don't have to see all the others. So I'm going to plug in 0, 4, and -2. So we can see that 0 is not a root because it does not result in 0. 4 is a root because it results in a y value of 0. -2 is not. So 0, no. 4, yes. -2, no. Number 16 on CP and number 18 on honors is the same type of question. It says, is -3 a root of this equation? So we'll do the same process. I'll plug this equation in, x to the 4th minus 2x squared minus 3x plus 1. Oh, sorry, I need to go to the table, not the graph. And I'm going to plug in -3. That's the only one that matters. And it does not result in a y value of 0, so it is not a root. So -3 is not a root of that. Alright, number 17 on CP is number 19 on honors. It says write the equation of a polynomial that has the roots of 3 and -2. So remember, to do this, you just have to remember x minus the root. So I will do x minus 3. Just a second, I'll get that stuff cleared off first. Here we go. X minus 3 and x minus -2, which gives me x plus 2. This is my equation, but I do need to go ahead and FOIL this. X times x is x squared, and plus 2x minus 3x minus 6, and then combine the like terms in the middle. Plus 2x minus 3x gives me minus x minus 6. So this is a polynomial that has the roots of x equals positive 3 and negative 2. Same type of question. It's number 18 here on the CP. It's number 20 on the honors. Similar process. We want to start by doing x minus each of the roots. So I'll do x minus 7, x minus 3i, x minus a negative or plus 3i. When we're foiling this, you should always do the ones with the imaginary first. So I'm going to start by foiling here. X times x is x squared. And then the whole reason we do these is it's going to cancel out the imaginary parts. Because look, you get positive 3ix minus 3ix. So those two terms cancel out. So I just end up with x times x is x squared, and then negative 3i times positive 3i. Negative 3 times positive 3 is negative 9. I times I is I squared. And remember, I squared is equal to negative 1. So this turns that into x minus 7 times x squared plus 9. Because we end up with negative 9 times negative 1, which is plus 9. So finally, we'll FOIL this out, getting x cubed minus 7x squared plus 9x, and then negative 7 times 9 is negative 63. (19) Use a graphing calculator to determine the number of real and imaginary roots for this equation. So first of all, we know the total number of roots for this is 3 because that's its degree, it's x cubed. I can look at the graph of this to look for x-intercepts because the number of x-intercepts that it has tells me the number of real roots it has. So I have x cubed plus 2x squared minus 3x. So I know there are 3 roots in total, and I can tell how many of them are real by seeing how many x-intercepts there are. So there's 1, there's 2, and 3. So it is hitting the x-axis 3 times, which tells me all 3 of the roots are real. So 3 real roots for this one. Then number 20, same basic process. We see the degree is 4, it's x to the 4th, so there are 4 roots total. And I can figure out how many of them are real by looking for the number of x-intercepts. Four roots total, because that's the degree. And we'll see how many x-intercepts there are to figure out how many real ones there are. I see 1, and 2. So notice it only hits the x-axis twice. So that tells me there are 2 real roots. Two real roots because there's 2 x-intercepts. And since there are 4 total, that tells me the other 2 must be imaginary. Okay, I'm going down to, this is 21 on CP, this is 23 on honors. So use the discriminant to determine the number and type of roots for each of the following quadratics. Remember, the discriminant is b squared minus 4ac. This is our a, our b, and our c. So we do b squared minus 4ac. So that's 49 plus, I think 16. Nope, 32, sorry. Which gives us 71. Since that is a positive number, that tells us that this quadratic has 2 real roots. For b, our a is 1, right there in front of x squared. Our b is negative 1. Sorry, it's not quite aligned right. And then our c is positive 6. So a is 1, b is negative 1, c is positive 6. I'll switch colors and make it easier to see. We'll do b squared minus 4ac gives us a positive 1 minus 24. That's negative 23. When we get a negative result, that tells us there are 2 imaginary roots. And finally, on this last one, we have an understood 1 for A, 4 for B, 4 for C. We do b squared minus 4ac gives us 16 minus 16, which is 0. When there is a discriminant value of 0, that means we have one unique real root. So technically there are 2 real roots, but they're the exact same number. So there's just one unique real root. Remember, feel free to move about this and pause anywhere you need to look over it more. CP, your last one, 22, 24 on honors. Determine the degree and leading coefficient for the following equations. Hopefully this is very easy for everyone. Degree and leading coefficient. Okay, the degree, that is the highest exponent. So for A, that is at 6. The leading coefficient is the coefficient in front of it, which is 7. Okay, here the highest exponent is a 2. And the leading coefficient, the coefficient in front of it, is 6. For this last one, the 2 is the highest exponent, so that's the degree, and negative 8 is the leading coefficient in front of it. Very good. So, CP, that is all your problems. You can hit stop right now. Honors, I'm now going to go back and do the 2 I skipped on yours, which on yours is number 12 and number 16. Okay, here's number 12. Find the slant asymptote. Remember, to do the slant asymptote, we divide, but then we ignore the remainder. So we can use synthetic division here. Negative 4 is what will make the denominator equal 0. Then I pull the coefficients, which is 1, 5, and 21. Pull down the 1, negative 4 times 1. Add those together, get a 1. Negative 4 times 1, negative 4. So we get a remainder of 17. So we get 1x plus 1, and then this would be the remainder. But in slant asymptotes, we don't care about the remainder. We just keep the other part. So actually I put y equals, but our slant asymptote is y equals x plus 1. And 16. Y varies directly as x, so directly means we multiply, k times x, and inversely, so we divide, inverse, divide, as the cube root of z. So I'm just going to write z to the 1/3. You can write the cube root if you want, either way is fine. And sorry, I'm missing a number on that one, hold on, let's see what it is. Y equals 40. Y equals 40 when x equals 20 and z equals 8. Okay, so 8 to the 1/3 power is 2. So that tells us 20 over 2 is 10. So I can divide both sides by 10, and I get that k is equal to 4. So I can rewrite the equation as y equals 4k over z to the 1/3. Then it says to find y when x is equal to 8 and z is equal to 27. So we end up with 32 over 3. Alright, honors, thank you for your patience. I know the numbering is a little off, and thanks for waiting to the end to see 12 and 16. But to all of you, I hope this helps you a lot, and good luck on your tests.